Hello. In this video, we're going to be talking about just the basics of doing a hypothesis test and some of the different elements that you are going to need to find when performing a hypothesis test. In our first example, when 40 people used Weight Watchers diet for 1 year, their mean weight loss was 3 pounds and the standard deviation was 4.9 pounds. Use a 0.01 significance level to test the claim that the mean weight loss is greater than 0. The first step will be to identify the null hypothesis and the alternative hypothesis. To do this, the first thing that you want to do is write out what the claim is. And so we're going to use the 0.01 significance level to test the claim that the mean weight loss is greater than 0. So the claim is that the mean weight loss, that's mu, is greater than 0. And then you want to write out the opposite. And the opposite mathematically to greater than is less than or equal to. So mu is less than or equal to 0. And the null hypothesis is the one that contains the equal sign, and so that's going to be the opposite in this case. And we never have an inequality in our null hypothesis, so the null hypothesis will just be that the mean mu is equal to 0, and then the alternative is the other one. So this became our null, and so this becomes our alternative. So our alternative will be that mu is greater than 0. I always make a little note to myself that where the claim is, because where the claim is will determine how you make your conclusion statement at the end. So I always make a little note there telling myself that the claim is in my alternative hypothesis, because where your claim is will decide how you make your conclusion statement when you're done with your hypothesis test. The alpha level is the significance level of the test, and so that's 0.01. We're testing at the 0.01 significance level. What is the sampling distribution of the sample statistic? Whenever you're testing a mean, it's going to be the t-distribution when you're taking a sample. If you're told that you know what sigma is, then you would use z, but again, we're not told that we have the population standard deviation. We have a sample standard deviation. If it's a population standard deviation, they will specify that it's from a population, or they will actually use the symbol sigma to denote that. So this would be t, and the formula for this sample statistic is x bar minus mu divided by the standard deviation over the square root of n. So this would be your sample mean. This is the mean that we're testing, so this would be 0, and we'll compute this statistic in a little bit here. Is the test two-tailed, left-tailed, or right-tailed? And that's based off of your alternative hypothesis. This is greater than 0, and so this is right-tailed. So whatever direction this inequality is pointing, that's what tailed test you have. So this is a right-tailed test. The next part, what is the value of the test statistic? T is equal to x bar minus mu over s divided by the square root of n. The mean for this problem was 3. Mu is 0, so that's what we're testing. This is coming from your null and your alternative hypothesis, the 0 is. The 3 was from the sample. And then our standard deviation from up in the problem was 4.9. And we had 40 test subjects, so we're dividing by the square root of 40. 3 minus 0 is just 3, so it's going to be 3 divided by, and then just make sure you put that denominator in parentheses when you put it into your calculator. And when you put this in your calculator, you should get 3.87. My stat lab is very picky, and you don't want to do any rounding until the end. So just make sure that you're careful about that. Next, what's the p-value? So the p-value is the area from your test statistic out. So this is a right-tailed test. Remember, the t-distribution is very similar to the normal distribution. It's a bell-shaped curve, and it's symmetric, and it's centered around 0. So here is our test statistic, 3.87. And so we want the area to the right of this. So we need to go find our t-table. So let me bring that up. So here is our t-table. We had 40 test subjects, so that means that we have 39 degrees of freedom. And the only way for you to get a p-value from these tables is to get a range. So this isn't really the best way to do it. I would say that if you're going to use your tables to do the tests, you're going to want to do critical values because, like I said, you can only get a range from your table for this particular test. So if I wanted to find the p-value here, I would look at the 39 degrees of freedom line and find the value in the table that is closest to my test statistic, which was 3.87. And we can see that 3.87 is bigger than this 2.708 number. And so when we go up here, we see that, and this is area in one tail. So all I can get from the table is that my p-value is less than 0.005. So that's all you can get from the table. We can find our critical value. So the level of our test was 0.01, and this is an area in just one tail. So we can find this using the table. So let's bring the table back up. And area in one tail is the top numbers. So here's an area of 0.01 in one tail. So we would want to use this second column of numbers and go down to 39 degrees of freedom. So here's 39 degrees of freedom, and so this would be our critical value, 2.426. And what is the area of the critical region? That is the alpha level, so just 0.01. So they're just trying to really drive home the fact that the area of the critical region and the significance level are the same. So that's what they're really trying to get across in that one. You can do all of this on your calculator. So if you want to perform this test on your calculator, you're going to want to push the Stat key. And then arrow over so that you have tests highlighted. And then for this one you would want option, on my calculator it's option number 2, and it's a t-test. On my calculator, it just asks me to fill in everything. I'm going to do this from statistics. You can either choose to do it from statistics or from data in a table. So make sure that you make that selection. And so you'd want to enter in 0 for your mean, and it has a little 0 there. That's because it's stating that it's from the hypothesis. And then enter in a value for x bar, your mean, from the sample. So that was 3. And then you want to enter in the standard deviation. So that was 4.9. We need n. And n in our case was 40. And then you also have to select the alternative hypothesis. Ours was a right-tailed, so arrow over to greater than mu sub 0. Hit enter so that that one is selected, and then arrow down to calculate, and then hit enter. And so it tells us what our alternative hypothesis is. It gives us the test statistic. It gives you the p-value. So the p-value that you get on your calculator is 2.0026, and then there's an e negative 4. It also gives you, spits out again what the sample mean was and what the sample standard deviation, and also n. So what this number is, this e negative 4 means move the decimal place 4 positions to the left. So if I move this decimal place 4 positions to the left, that would be the number 0.000200026. We can see that we have a really small p-value, and we will talk more about what all of this means when we actually start doing some hypothesis testing. In this video, we just want to go over what the process is and pick out the different little things that you need to find when you're doing a hypothesis test. In a Gallup poll, 1,010 adults were randomly selected and asked if they were satisfied or dissatisfied with the amount of leisure time that they had. Of this sample, 657 said they were satisfied and 353 said they were dissatisfied. Use a 0.01 significance level to test a claim that 2/3 of adults are satisfied with the amount of leisure time they have. Part A, identify the null hypothesis and the alternative hypothesis. In order to do this, we want to write out our claim and then the opposite. The claim is that 2/3 of adults are satisfied with the amount of leisure time they have, and we also need to determine which test statistic we're needing here, and this one is about a proportion, right? So they have one group is satisfied, the other group is dissatisfied. So there are two choices, and so that makes it a proportion. So we're saying that P, 2/3 of them are satisfied. So P is equal to 2/3 is the claim. The opposite mathematically would be that P is not equal to 2/3. And so the null is the one that contains our equal sign. So that would be P equals 2/3. And the alternative is P is not equal to 2/3. And our claim this time is in the null. So I always make a little note of that just because it's going to determine later on how I state my conclusion. What is the value of alpha? So that is the significance level. So alpha here is equal to 0.01. So that's the significance level of our test. What is the sampling distribution? Proportion is Z, and it would be P hat minus P divided by the square root of PQ over N. So that's the equation for our test statistic. Is this a two-tailed, left-tailed, or right-tailed test? This is two-tailed. Not equal to gives you a two-tailed test. Greater than would be right-tailed, less than would be left-tailed. What is the value of the test statistic? So the first thing that I need to do here is calculate what p hat is. P hat, remember, is x divided by n. So the part of the people that we're interested in divided by the total. The total was 1,010. And doing our test about people who are satisfied, 657 of them said that they were satisfied. So 657 divided by 1,010. And when you compute that, bring it out to 4 decimal places, and you should get 0.6505. So z is equal to p hat minus p over the square root of pq over n. P hat is 0.6505, and then minus p, which is 2/3, and I'm going to leave it as 2/3 right now. And that's divided by the square root of p, which is 2/3, times 1/3, over n, which is 1,010. You don't want to do any rounding in this until the very end, so that's why I'm leaving it as 2/3. So when you do your calculation in the numerator, you're going to want to make sure you put this fraction in parentheses. And then also, when you are typing in 2/3 times 1/3, just make sure that you put the 2/3 and the 1/3 in parentheses. So that's going to be really important when you're doing your calculations. So once you plug this into your calculator, you should get negative 1.09. This is from the normal distribution, so we can use our table to find our p-value. So let me pull up the table. And our test statistic is negative 1.09. And this is a two-tailed test. So we want to actually find the area from negative 1.09 out to the left, and also from 1.09 out to the right. And since this is symmetric, we're just going to multiply the area that we find by looking up negative 1.09. So we need the negative side of the table, negative 1.09. So here's negative 1.0, and then we want to go all the way out to the end, 0.1379. And if you multiply that by 2, you get 0.2758. So again, when you're doing a two-tailed test, you have to remember to multiply your p-value that you get from looking up your test statistic in the table by 2, because you want both of those areas. Next, what is the critical value? So the level of our test was 0.01, and it's a two-tailed test. So the area in one tail then would be, so this area alpha gets split between our two tails, and so the area in one of our tails is 0.05. So to look up the critical value in a z table, you would find this number in your table. So inside the body of the table, we need to find 0.005. So let's see here, 0.005. So there's a star in between 0.0051 and 0.0049. So follow that back to where it came from, and we get 2.575. And we want both the positive and the negative because this is a two-tailed test. Again, you can do this on your calculator. To do this on your calculator, you're going to want to push the Stat key, and then go over to Tests, One proportion, Z-test. So on mine, that's option number 5. You're going to need to enter P sub 0 . This is 2/3, but the calculator needs you to put in a decimal. So here you will have to round. So put in a bunch of 6s and a 7. Then you need to give it X. That was 657. And then you need to give it N, which was 1010. And then you also need to select your alternative hypothesis. Our alternative was not equal to. So make sure that you have that selected, and then arrow down so that calculate is blinking, and then push enter, and it gives you all of your necessary information. It gives you Z, your test statistic, P in this is your p-value, p hat it gives you, and also N. So again, you can get all of this information from your calculator. The last example here, the Brazil vending machine dispenses coffee, and a random sample of 27 filled cups have contents with a mean of 7.14 ounces and a standard deviation of 0.17 ounces. Use a 0.05 significance level to test the claim that the machine dispenses amounts with a standard deviation greater than the standard deviation of 0.15 ounces specified in the machine design. So write down your claim. The claim is that the machine dispenses amounts with a standard deviation greater than the standard deviation of 0.15. So sigma is greater than 0.15 is the claim. And then the opposite. So opposite of greater than is less than or equal to. The null hypothesis is always going to be equals, so the standard deviation is equal to 0.15, and then the alternative is the one that doesn't contain an equal sign, so that would be greater than. Sigma is greater than 0.15. And also make a note that this is your claim. Alpha is 0.05, so that's the significance of our test. The sampling distribution is chi squared, and it's n minus 1 s squared over sigma squared. This test is a right-tailed test. So this is coming from your alternative always. Since it's greater than, it's right tail. The value of the test statistic, so now I want to plug our information in. We had 27 was our sample size, so 26 is n minus 1. And then our standard deviation is 0.17. We square that, divided by sigma squared, so that was 0.15, and square that. When you plug this into your calculator, you should get 33.396, and I'm going to take this out to 3 decimal places. Just be careful in my stat lab that you put in however many decimal places they're asking for. If they wanted 2 decimal places, you would enter 33.40. We're not going to do the p-value on chi-squared distributions. You can get them if you have a graphing calculator, but if you do not have a graphing calculator, then getting p-values is rather cumbersome. What is the critical value? So we have a right-tailed test, and our significance level is 0.05. So I need to bring up the chi-squared table. So here is the chi-squared table. We're doing a right-tailed test with an alpha level of 0.05. The table gives us areas to the right, and so because we're doing a right-tailed test and the significance level of 0.05, that means that I have an area of 0.05 in my right tail. So here is the 0.05 column. I want to go down to 26 degrees of freedom. So 26 degrees of freedom is this blue line right here, and make sure that we get the right column. So it's 38.885. So remember, the chi-squared distribution starts at 0, and it has sort of this long skewed right. So our critical value is 38.885. And our test statistic is 33 point, so this is our critical value, and our test statistic is less than that, 33.396. So just to give you a little heads up, so here we would fail to reject because our test statistic is not in the tail. So if it would have ended up in this tail over here, then we would reject our null hypothesis. And the area of the critical region, this is always just your significance level. So that would be 0.05. Okay, so that's it for this video. Let me know if you have any questions. And again, this is just finding the different pieces of a hypothesis test. The following videos will be about actually performing hypothesis tests for each of these 3 different test statistics. I hope you're having a wonderful day, and let me know if you have any questions. Thanks.